everyone. For today's lesson, we are going to learn how to graph sine and cosine functions. For this lesson, you will need something to write with, but especially a highlighter or some sort of color to help you with the axes that we are going to be drawing with our graphs today. Before we get started, it is imperative that you complete this warm-up as it is the foundation of our lesson for today. There are 10 different expressions that are all based off of the unit circle and should be relatively familiar to you. I would like you to please evaluate the sine of 0, the sine of pi over 2, the sine of pi, the sine of 3 pi over 2, the sine of 2 pi, the sine or cosine of 0, cosine of pi over 2, cosine of pi, cosine of 3 pi over 2, and cosine of 2 pi. If you need to draw out a unit circle to help you with your evaluation, that's perfectly fine, but please pause the video and complete this warm-up. And when you have an answer, please go ahead and restart the video and we will see how well you did. All right, let's go ahead and start off by drawing a really quick sketch of a unit circle. So this is my unit circle, and I know that 0, pi over 2, pi, 3 pi over 2, and 2 pi are our quadrantal angles. They are located right here on the quadrants, and we're going to refer to the ordered pairs that are on this quadrant. And our ordered pairs are 1, 0, 0, 1, negative 1, 0, and 0, negative 1. The very first set that we needed to evaluate were sine functions, and sine is the y part of our ordered pair. So the sine of 0, if we were to go to where 0 degrees is, it's the y value, and the y value here is 0. Pi over 2 is this ordered pair, and sine of pi over 2 is the number 1. The sine of pi, which is halfway around the circle, is going to be 0. The sine of 3 pi over 2 is going to be negative 1, and the sine of 2 pi will be right back at 0. So that is how you find the sine of all of our quadrantal angles. Cosine, well, that is the x part, or the x value of all of our ordered pairs. So the cosine of 0, that is 1. The cosine of pi over 2, that's 0. The cosine of pi is negative 1. The cosine of 3 pi over 2, that's 0. And the cosine of 2 pi, we're right here back at 1. So hopefully you were able to get these answers correct and you feel pretty comfortable coming up with and evaluating each of these functions at our quadrantal angles, because these values are what we're going to use in example number 1. Example number 1 asks us to make a table of values to determine what the graphs of the y equals sine of theta and y equals cosine of theta would look like. So if you think about it, the sine of theta if you think about it, theta is our angle that we are referring to. It's our input. So we are inputting an angle like sine of 0. And then we get an output, which is a y value, and we got 0. And if you look at these tables right here, notice that we are using 0, pi over 2, pi, 3 pi over 2, and 2 pi. And when it comes to our output, those are going to be all of the answers that we got in our warm-up. The sine of 0, we know is 0. So if our input is 0, our output would be 0. If our input is pi over 2, our output is 1. Then the sine of pi is 0. The sine of 3 pi over 2 is negative 1. And the sine of 2 pi is 0. So what we're going to do now is we are going to plot these ordered pairs on our coordinate plane. So I'm going to plot 0, 0. Then I have pi over 2, 1. Then I have pi, 0. 3 pi over 2 is going to go down to negative 1. And then back to 2 pi, which is 0. And the way that we graph this is it's a smooth curve. So we graph it kind of in a curvy parabolic way. So it should look like individual or mini parabolas. It should not look like a sharp zigzag. So it needs to be a smooth curve. And what you guys just created, or what we just created right here, is what we call a cycle of a sine function. This is also known as a sine wave. So this is just one piece of a full function. So now if you think about it, on a unit circle, are we allowed to go around the circle multiple times? The answer is yes. When we go around the circle multiple times, we're going to land at what we call coterminal angles, angles that have the same exact position as other angles. So this is going to continue, and we are allowed to go counterclockwise, which is our positive angles, as well as clockwise, which is our negative angles. So we are allowed to go forwards and backwards. So what we have graphed right here is what we call a cycle. One cycle. And this cycle repeats. Like if we were to look at, so right now we're at 2 pi, our next location is going to be right here at 1, which is like 450 degrees right here. That would be 90 degrees past 360. Or in that case, it would be 5 pi's over 2. If we were to go to the next number, we would land at 1. So our next value is going to be up at 1, and that is going to be our end behavior on one side of our graph. On the other side of our graph, if we were to go backwards, so right now we're at 0, if we were to go clockwise, we would go down to our y value being at -1, so negative pi over 2 would be at -1. Negative pi, we would have a sine value of 0 or a y value of 0. 3 pi over 2 or negative 3 pi over 2, we would land at 1. And then finally, negative 2 pi, we'd land right here back at 0. And if we were to continue this graph using a smooth curve, notice that we have just created waves. And we created another cycle of this function. If we were to continue going backwards or going in a clockwise motion, we would land at -1. So we would anticipate that our next location will be pointing down. These end behaviors are really important, and that is something that I want you guys to know and study. What we have just graphed right here is a sine function. It is a function that is known as periodic because it repeats itself in a pattern, or it has a pattern that repeats itself over and over again. And each time that it goes through one full cycle, one through motion, we call that a cycle. And so we'll go back through the vocabulary in just a second after we talk about cosine functions. Before we talk about cosine functions, though, let's talk a little bit more about our sine function. The first thing I want you to know is that there exists a new word called amplitude. And what amplitude represents is half the difference between our maximum value and our minimum value. Typically, amplitude is your A value. So your A value, if you think back to all of the functions that we've graphed so far this year, it's always the number that's in front of whatever operation we are dealing with. So in this case, there exists an invisible number 1 right here, and that A value represents our amplitude. Period represents how long it takes to go through one cycle. So in this problem, we start at 0, up, 0, down, 0, which is a cycle of sine, and it took 2 pi to get there. That is known as a period. How long does it take to go through one cycle? And I'm going to write down what I just said, where I had 0 up, 0 down, 0. That is a cycle of sine. So 0 up, 0 down, 0. That is our pattern that we are going to be using. This is something I need you to make sure that you know and study when it comes to sine. Another thing I need you guys to know is that when it comes to the parent functions of sine, sine always starts at 0, 0. Always starts at 0, 0. And the last x value that you're going to have in your table, this always represents the period. So I will repeat this. Sine always starts at 0, 0, and 2 pi, whatever that last x value is, that's going to be your period. And whatever your first x value is outside of 0, 0, that is going to represent your increments and what you make your scale go by on your graph. So notice that our scale went by pi's over 2. As we get into more complicated graphs on the next page, you will notice that the period is going to change. So next we have ourselves an axis, and all of our graphs are going to have an axis, and our axis is always going to be based on our k value. So what I just drew for you guys here is y equals 0, and this 0 is our k value. So in our next lesson, we will discuss more about k values because we're going to be working with transformations of functions like y is equal to a times the sine of b times x minus h plus k. It'll be that number that you are adding on the outside of the function. In this very plain and simple parent function, the most basic of sine functions, notice that our k value is 0. We're not adding any numbers on the outside. So therefore, our axis is going to be at y equals 0. For all of your graphs, the expectation is that you're going to draw this axis every single time, and it essentially is like your reflection line, where you can see that each of the curved pieces, they're kind of like reflected or cut in half going straight across, and then that's going to be your axis. We always use a dashed line to express it as well. Our minimum value is located at -1. Our maximum value is located at +1, which means that that's going to affect our range. Our range is going to go from -1 to +1. Or if you want to write it using inequalities, we have -1 is less than or equal to y, which is less than or equal to 1. When it comes to domain, there doesn't exist a vertical asymptote that prevents us from having an x value beyond this graph, so therefore our domain is going to remain all real numbers. So now let's go ahead and talk about a cosine function. So using our values that we came up with in our warm-up, we're going to be evaluating, once again, the cosine of 0, pi over 2, pi 3, pi over 2, and 2 pi. Our quadrantal angles from our unit circle. The cosine of 0 was 1, so we're going to put in the number 1. Then cosine of pi over 2 was 0. Cosine of pi is -1. Cosine of 3 pi over 2 is 0, and the cosine of 2 pi is 1. So we're going to go ahead and plot these ordered pairs onto the grid. So I'm going to go ahead and plot 0, 1. And then I have pi over 2, 0, pi down to -1, 3 pi over 2 to 0, and 2 pi going all the way up to 1. And this looks like it's going to be a V, but it's actually supposed to be kind of curved. Not supposed to be something that is like a sharp zigzag. That is not how cosine or sine functions are. They are curves, they are waves, they're not zigzags. So please make sure that you pay attention to that. So if you can think about this as parabolas or parabolic, our graph, our next location is not going to be going up. So we are reaching a maximum here. And if you look at all of our values on the quadrants are either ones or -1s. So our maximum value that we are going to have is a 1, so we would not have an arrow pointing up. And if you were to look at going around our unit circle one more time, so we've already made it around the unit circle, we landed at 1, my next x value is going to be 0. So I know that I've reached a max value, and I'm going to point my arrow right back down. So I really want to encourage you guys to please watch your end behavior and really anticipate what is going to be the next location. Is your next location going up or is your next location going down? Where is it going to be? Pay attention to those maxes and mins as you are graphing. Going backwards, if we were to go clockwise, we would go down to 0, down to -1, back up to 0, and then back up to 1. So we're going to go ahead and plot those. So in going in the pattern, I know I'm going down through 0. The negative pi would be at -1. Then we've reached our minimum value, so we have to go right back up. So -3 pi over 2 will be 0. And -2 pi will go up to 1. And I'm going to connect these points with a smooth curve. And I know that the next point is not going to be going up. I've reached a max value, and I'm going to be pointing my arrow down. So what you see here is one cycle of cosine. It is a little bit different than the cycle of sine. Both are wavy, both have their own thing going on, and they do look very similar. It kind of looks like the graph has just been shifted left or right, and in some respects, that's kind of true. But I really want you guys just to pay attention of where you're starting when it comes to cosine compared to sine. Just like with sine, where we start at 0, 0, the starting point for cosine will always be 0 and then your a value. So this is going to be our a value. So instead of it being just 0, 1, which is the most basic function of cosine, it's going to be at 0a, and I'll talk more about that on the next page. But this is something I need you guys to always pay attention to. Still true is that first regular x value will always be your increments of what you are going by and how you're going to create your scale on the x-axis. And your last x value of your table will always represent your period. So that is consistent between sine and cosine functions. Cosine function is different than what a sine function is in terms of its pattern. Sine was 0 up, 0 down, 0, but cosine starts up. It goes through the pattern of up, 0, down, 0, up. And that's the pattern that you will follow. Up, 0, down, 0, up. The amplitude is still going to be your a value. It is the absolute value of your a value, and it represents half the difference between your maximum and your minimum. Your period still represents how long it takes to go through one cycle of cosine, or one cycle period. Your axis is still going to be located at y equals 0, and it's still based on the k value. And that k value is going to come from, eventually once we get into another lesson, a times the cosine of b times x minus h plus k. It's going to be that k value, the number that you're adding on the outside. But if you see right here, we're not adding any numbers on the outside, so therefore we assume 0. So if I were to draw that in, draw on my axes, it's going to be a dashed line on the x-axis. Our minimum is still -1, our max is still +1, which means that my range is going to remain the same as sine, where we can write it as -1 is less than or equal to y, which is less than or equal to +1. And our domain is still going to be all real numbers because there doesn't exist an asymptote, a vertical asymptote, preventing an x value from working. So let's go ahead and recap a little bit more on the characteristics of sine and cosine functions. First, the domain of each function is going to be all real numbers. And we always write that as a symbol with an R that has like the double lined R. The range of each function, in this case, is going to be -1 going all the way to +1. That is our range for these basic cosine and sine functions. These are the basic ones. The parent of the parent functions. Amplitude is the functions of the functions graph is half the difference of the maximum value and the minimum value. So we can write it as 1/2 capital M minus little m, or you can write it as 1/2 times the max value minus the min value. That's going to equal the amplitude. And one thing I want you guys to know about amplitude is that it's always positive. So if you notice that your A value is negative, your amplitude will be the absolute value of A. So I'm going to put absolute values of your A value. That's going to represent your amplitude. Now, each of these functions will repeat in this wave over and over and over again. And because each function is what we call periodic, that means that the graph has a repeating pattern. It repeats the same pattern of up, 0, down, 0, up, or 0 up, 0 down, 0, depending on what type of function it is, over and over and over again. Now, the shortest repeating portion of the graph is called a cycle. The horizontal length of each cycle is known as a period. How long does it take to go through one motion of 0 up, 0 down, 0? Or how long does it take to go up, 0 down, 0 up? So period represents the horizontal. So you're asking yourself, what is the horizontal, or excuse me, how long does it take to travel one cycle? That's going to represent your period. Here, it was 2 pi. So 2 pi was that last x value of our table. It was the last value of your full cycle that you went through. It's where you landed in either the 0 position or the up position at the very end. So right here with sine, it was where you landed at the very end. That's going to represent your period. All right, so let's go ahead and talk a little bit more about the information pertaining to these types of functions, because now we're going to be taking it to the next level by really changing things up, like changing the amplitude and changing the period. A change in amplitude comes from your A value. A denotes a change in amplitude. So what you're going to see is that there's going to be a number that's going to be right in front of your A value, of your sine or cosine functions. That value, we kind of view it as like a vertical stretch of our graph, and it affects the maximum and minimum values. When it comes to our period, period is going to come from a new letter that is our B value, and B is going to be this number that is right in front of X. So it comes right after the word sine or cosine. And that B value helps us to come up with our period. Now, based on the most parent of parent functions, our normal period is 2 pi. But if we suddenly have a B value there, it's going to affect our period. So the way that we find our period is to go 2 pi divided by B. Now remember that period is how long it takes to go through one cycle. So it says absolute value of B, and that's because your B value can be negative, but for our class and where we are at, our period is only going to be positive. So our period, once again, is going to be equal to 2 pi divided by B. And this is something that I want you guys to please make sure that you know and study, because we will be using this as we are creating our tables and our graphs. So that's our period. When it comes to increments, remember that the increments was always what was going to be in that first X box, like that first X position outside of 0, 0, or 0A. So one way to come up with that value, well, actually there's 2 ways, and both of these ways are identified right here. So our normal critical values were every pi over 2 units, and those values came from our unit circle. So if you want to figure out what your new increments are going to be, you're going to divide pi over 2 divided by b. So pi over 2 divided by b will give you your increments. Like, are you going by pi's over 2, or are you going by pi's over 4, or are you going by pi's over 6? What are you going by? Are you going by 2's? That will tell you your increments. That is one approach, and it's a very useful approach for coming up with your increments. Another way, which is a way that I really like, is it helps you to identify all of your values. And that is the 1/4 times your period, 1/2 times your period, 3/4 times your period, and 1 times your period. This is another way to come up with those critical values. And when we say critical values, we are referring to the x values of the table. Those are your critical values. Those are going to be the x values that we are going to be graphing. So the 1/4, 1/2, 3/4, and 1 of the period, let me go ahead and explain that really quick. So flipping back to the first page, notice that the x values that we used were on the quadrants. So if we think about it, pi over 2 is 1/4 of the unit circle. Pi is 1/2 of the unit circle. 3 pi over 2 is 3/4 of the unit circle. And then 1 full time around the unit circle will land us at our period. If our period is going to change, all we need to do is multiply that period by 1/4, 1/2, 3/4, and 1 to come up with our values. So that's another approach. So one approach is to do pi's over 2 divided by b and just count. Another approach is to use the 1/4, 1/2, 3/4, and 1. I like this approach because I find it to be visual. So here are the steps that you guys will need to do when it comes to graphing these functions. The first thing you need to do is recognize what type you have. Do you have a sine or a cosine function? And in this picture, this is a sine function. And sine functions always start at 0, 0. That is always going to be your first ordered pair. Always. Then the second thing that you are going to do is, after you identify if you're starting at 0, 0, or if you're starting in a different location, the next thing that you want to do is you want to, so I'm going to write step number 1 is, of course, locate your starting point. But we want to identify your A value and your B value. Your A value is going to tell you what your amplitude is, and your B value is going to help you identify your period. So step 2 is to use your B value to find your period. That's going to be from the formula 2 pi divided by b. Once you know your period, it's going to go into this last position, 2 pi divided by b. And to find all of the other x values, which is going to be step 3, we want to find the x values, which once again, those are called critical values. You would either go pi over 2 divided by b, put that answer here, and then just start counting by it, or you would go 1/4 times your period, 1/2 times your period, 3/4 times your period, and then 1 times your period, which 1 times your period is your period. So that makes sense right there. And whatever those values are going to go inside of the x position of the box. So whatever they are is going to go into that position. And if you look at these ordered pairs that I have on the pictures, notice that up here is 1/4 times 2 pi over b, and 2 pi over b is just your period. 1/4 times the period, 1/2 times the period, 3/4 times the period, and back up here we have 1 times the period, which is the period itself. The y values are going to follow, so that's going to be step number 4, is to find your y values. And for our finding our y values, we're going to use patterns. So find y values using patterns. So remember that sine has its own pattern. So this is using patterns. Sine has its own pattern. The pattern is that it starts at 0 and it goes 0 up, 0 down, 0. So 0, it's going to go up to your A value, because remember that our A value is not necessarily going to be 1. It could be a different number. So 0 up to your A value, back to 0, then down to your negative A value, then back to 0. So 0 up, 0 down, 0. Cosine is going to have the same exact steps. So here's cosine. This is a cosine function. Cosine is not going to start at 0, 0. Instead, it's going to start at 0, A, whatever your A value is. And that is always going to be your starting point. So that is something to study. Does cosine start at 0, 0, or does cosine start at 0, A? It starts at 0, A. It starts up. When it comes to finding your x values, we're going to follow the same exact steps as before. It's going to be 1/4 times your period, 1/2 times your period, 3/4 times your period, and 1 times the period. And those values are going to go right here into the x position of your table. Your y position is going to be up 0, down to negative A, back to 0, and then up to A again. Up, 0, down, 0, up. So that's the pattern. Up, 0, down, 0, up. That is something to study. All right, so we've gone through a lot of the information. Let's go ahead and start graphing. So looking at example number 2. Example number 2 is asking you to graph each function, finding amplitude, period, 5 key points, domain, and range. So our amplitude in this case, remember that's your A value. And in this case, our A value is the number 3. Our B value is the number 1. That is the number that's in front of X. So when we come up with our period, that's going to be 2 pi divided by 1, which is 2 pi. My axis is going to be y equals 0 for every single one of these graphs. And I'm going to graph it right away so that I don't forget. So that's going to be one of the first things that I do. After I have my axes, I'm now going to go ahead and draw in. So I guess that was step number 5 I forgot to write down. Step number 5 is to label and draw axes and graph. So that is step 5 for all of these functions. So let's go ahead and do that. So far I've drawn in my axes. I'm going to label it in just a second because I need to come up with my table of values. So my x values, remember that this is cosine. So cosine starts at 0, 3, 0 your A value. And my x values are going to be 1/4 times my period, which is 2 pi, 1/2 times 2 pi, 3/4 times 2 pi, and 1 times 2 pi. And if it helps you to make that 2 pi over 1, that's perfectly fine. We're just going to multiply straight across. So this is going to be 2/4, which is pi over 2. 2/2, that's going to cancel away, leaving us with pi. This becomes 6/4, which is 3 pi's over 2. And 1 times 2 is 2 pi. So all I did was simplify each of these expressions to come up with my x values. Remember that another approach is to simply go pi over 2 divided by 1, which is pi over 2. And then we would count. This is 1 pi over 2, 2 pi's over 2, which is pi, 3 pi's over 2, and then 4 pi's over 2, which is just 2 pi. So that is 2 approaches that you can use in order to come up with your x values. Your y values, remember that this is cosine, so it follows the pattern of up, 0, down to negative 3, 0, back up again to 3. Up, 0, down, 0, up. All right, before I continue, I need to make sure that before I graph, I need to label my axes. So labeling axes is going to be a step that I need you to absolutely do. So since my maximum value is going to be 3, I'm going to mark up the number 3, and my minimum value is going to be negative 3. So I'm going to mark that up as well. My increments are pi over 2, so I'm going to label pi over 2, pi, 3 pi over 2, and 2 pi. On the other side, I have negative pi over 2, negative pi, and then negative 3 pi over 2. So at least label one positive cycle and one negative cycle on the x-axis. So I'm going to be looking for your labels. Now it's time to plot these points. So I'm going to plot 0, 3, pi over 2, 0, pi going down to 3, or negative 3, 3 pi over 2, 0, and 2 pi going up to 3. So what I have here is one full cycle of cosine. Now the expectation is that you are going to continue this pattern on both sides. So once we've reached this maximum, we would anticipate that our next location would have to be 0. So I'm going to plot 0. Then after that, it has to go down to negative 3. Then my next location has to be up at 0. So if you want to continue with this drawing, I would anticipate that the next one would be 0. And we're going up to 3 and then back to 0, where I would anticipate that my next point would be down to negative 3. That is a continuation of a cycle. Going backwards, I would anticipate that my next point would be at 0, and then going down to negative 3, and then back up at 0, where my next location will be located at positive 3. So I'll make sure that I have my end behavior graphed appropriately. My domain is going to be all real numbers, just like any other function. So it's always going to be all real numbers. And my range this time is going to be from negative 3 to positive 3. That's my minimum value all the way up to my maximum value. All right, let's go ahead and look at example number 4. So I would like you to please go ahead and try example number 3 and example number 5 on your own. But before you do those, let me go through example number 4 next. Example number 4 is a little bit different. And the reason why it's different is now instead of my A value being a different number, A value is going to be 1, but now my B value is the number 3. So how does that B value change everything? Well, it's going to change how quickly we go through one full cycle. That's what changes it. That's a period. How long does it take to go through a cycle? And now that's going to be different than all of the other functions that we have. So my amplitude is a 1. My period is now 2 pi divided by my B value. And since my B value is 3, it's 2 pi over 3, and I can't simplify it anymore. My axis is still going to be at y equals 0. And I'm going to graph that right away so that I don't forget. So now I'm going to use that period to help me to come up with my x values. Recognizing that this is a sine functions start at 0, 0. If I do my calculations correctly, my last x value should be 2 pi over 3 since that's my period. And now I need to come up with my increments. So I'm going to use that 1/4 rule. So 1/4 times 2 pi over 3, 1/2 times 2 pi over 3, 3/4 times 2 pi over 3. And then we have, of course, 1 times 2 pi over 3, which is 2 pi over 3. So down here, this is going to be 2 over 12, which is pi over 6. Then we have the 2's canceling away, which is pi over 3. Then the 3's cancel away, leaving us with 2 over 4, which is pi over 2. And then, of course, we have 2 pi's over 3. So if you're looking at this saying, okay, that was really fast and confusing, all I was doing was just simplifying the fractions. Remember that there exists another approach. That other approach is pi over 2 divided by our B value, which is 3. So that is really pi over 2 divided by 3 over 1, which is pi over 2 times 1 over 3, which is pi over 6. Notice that that is our first value. Pi over 6 plus pi over 6 is 2 pi over 6. And 2 pi over 6 simplifies to pi over 3. This would be 3 pi's over 6. 3 over 6 is pi over 2. And this is 2 pi's over 3, which would come from 4 pi's over 6. And 4 over 6 is 2 over 3. So that is another approach. When it comes to y values, we want to use the pattern for sine that's 0 up, 0 down, 0. So 0 up to the number 1, back to 0, down to the -1, and then back to 0. 0 up, 0 down, 0. All right, let's go ahead and label and then plot our points. So labeling, I only need to go up to 1, and I like to skip lines because I think that it makes the graph look nicer. So I'm going to make the y values go by 1 and -1 by skipping a line. And then I'm going to make these solid points, pi over 6, pi over 3, pi over 2, and 2 pi over 3. Going backwards, I have negative pi over 6, negative pi over 3, and negative pi over 2. Now that I have my labels, I'm now going to plot my points. I start with 0, 0, pi over 6, 1, pi over 3, 0, pi over 2 goes down to -1, then 2 pi over 3 goes back to 0, and I have just drawn in one full cycle of sine. And I'm going to continue this pattern. After 0, I'm going to go up to 1, then back down to 0, then down to -1, then back up to 0, and then up to 1. And I anticipate that my next point is going to be pointing down. Going backwards, I'm at 0 and I've already was up, so I don't want to go up again. I need to go down to -1, then up to 0, and then up to 1. I've reached 1, so my end behavior will be pointing down. And that is the graph of sine. So what I would like you to please do is please go ahead and pause the video, and please go ahead and try example number 3 and example number 5 on your own. And when you have an answer, please restart the video, and then I will show you what those answers are supposed to look like, and you can make some changes and adjustments to make sure that you know what you're doing. All right, let's go ahead and compare our answers. So here is our answer to example number 3. You should have had your amplitude being 5. Your period would be at 2 pi, so your x value should be 0, pi over 2 pi, 3 pi over 2, and 2 pi. Because our amplitude is 5, our a value is 5, and therefore our pattern for sine is 0, up to 5, 0, down to -5, and then 0. Range is going to be, domain is all real numbers, range is from -5 to +5, and then we would plot our points, making sure that your graph looks just like my graph. For example number 5, our a value is 1, our b value is pi, so that's going to be 2 pi divided by pi. The pi's cancel away, leaving you with the number 2. Y equals 0 will be your axes. We use that period of 2 to help us to come up with our x values of 1/4 times 2, 1/2, 3/4, and 1. So we end up with 1/2, 1 3/2, and 2. Our a value is 1, so we're just going to be starting cosine at 0, 1. So I have 1, 0, down to -1, 0, 1. And when you graph it, it's just supposed to look something similar to what you see here. And what I have down here is a little bit of a scribble of what I've noticed about students and their graphs. If you notice that one section is just a little too closer than another section, then that tells you might have done some graphing incorrectly. You really want your waves to be evenly spaced throughout the whole entire grid. So that's something to look for as well. All right, so on the next page, I would like to go through the team question with you, and then I'll have you do the solo in the same exact way that we just did it. So what's different about this problem is that now we have an a value and a b value. So I'm going to identify that my a value is 1/4 and my b value is pi. So my amplitude is 1/4 and my period is 2 pi divided by pi, in which the pi's cancel away, leaving us with the number 2. My axis is located at y equals 0, and I'm going to graph that right away so I don't forget. That is something I strongly recommend that you do. This is a sine function, so I know that sine starts at 0, 0. And now I'm going to use my period to help me come up with my x values. So that is 1/4 times 2, 1/2 times 2, 3/4 times 2, and 1 times 2. 2/4 is 1/2. 2/2 is 1. This is 6/4, which is 3/2, and 1 times 2 is 2. Sine follows the pattern of 0 up to 1/4, back to 0, down to -1/4, and then back to 0. So now I'm going to label, identify my domain and range. So I could probably do that right now. My domain is going to be all real numbers, and my range is going to go from -1/4 to +1/4. This is something that I already know is going to happen for these types of functions. We don't have any horizontal or vertical shifts yet. That's going to be coming up eventually. Not in this lesson, though. So I just want you guys to be aware of that. The range values are going to eventually change. Okay, so I'm going to label, and I really like using like skipping the line. So I'm going to skip a line and call this 1/4 and -1/4. I really like doing that because I think that it's like helpful to be able to see and graph or see what you're graphing. Then my scale is going to go by 1/2. So 1/2, 1, 3/2, and 2. -1/2, -1, -3/2. So now that I have my labels, I'm going to plot 0, 0. And I have 1/2, 1/4, 1, 0, 3/2 down to -1/4, and back to 2, 0. And I'm going to continue with this pattern of 0, up, 0, down, 0, up, and I'm going to draw my wave. And I would anticipate that my next point is going to be pointing down. So now going backwards, I'm not going to go up. I noticed that I was just up. I went through 0, so now I have to go down, 0, back up. So that's another thing that kids struggle with, is that they want to go up again, but that is awkward and we don't want to do that. We kind of want to make sure that this is flowing in the same exact motion every single time. And I wouldn't, this is my max point, so I'm going to have an arrow pointing down. All right, I would like you guys to please go ahead and complete the solo question on your own. And when you have an answer, please go ahead and restart the video and I will show you a picture of what that is supposed to look like. All right, let's go ahead and see how well you did. So your graph should look something like this. You should have had your amplitude being at 3. Your period, we were going 2 pi divided by 4. And 2 pi divided by 4 simplifies to pi over 2. Your axis is located at y equals 0 again. Range is all real numbers. Domain is -3 to +3. To come up with your x values, which is really one of the most important things, oh, I forgot to put in 3 and -3. Let me put that right there. I go 1/4 times pi over 2, which will give me pi over 8. 1/2 times pi over 2, which is pi over 4. 3 pi over 4 times 2, which is 8, so 3 pi over 8. And then 1 times pi over 2. And then cosine follows the pattern of up 0, down 0, up. And that's exactly what I have here. Up -3, back to 0, down to -3, back to 0, and up again. That is the end of today's lesson. If you have any questions over anything, please feel free to email me. Otherwise, I hope you have a wonderful day.